given a tubular heat exchanger consists of a number of tubes. So number of tubes equals to each of OD equals to 20 mm tube equals to 5 meters. So from this can we find out the total surface area of heat exchanger? So total heat exchanger surface area is number of tube multiplied by pi d O multiplied by L. Pi d OL is what? Is the surface area of one tube multiplied by number of tube will be the total surface area. Substitute for D0 equals to this value and L equal to this and NT equals to 1200. So surface area come out to 7 mm square, meter square. The hot fluids flows inside the tube and the cold is outside in opposite direction. So is it counterflow? The overall heat transfer rate is given as what? 320. So U0 equals to 320. Can we find out m dot h into Cph equal to Ch? So Ch equals to m dot h multiplied by Cph, that equals to 20 multiplied by 2000, so that equals to 40,000 watts per Kelvin. Similarly, we can calculate Cc value also. The Cc is given by m dot C into Cpc. M dot C is 5, Cpc is 4000, so that value equals to what? 20,000. Now from the value of Cc and value of Ch, so Ch is more, so this equals to C max and this equals to C minimum. So we have Cr equals to C minimum by C max. C minimum is 20,000 divided by 40,000, so this value equals to what? 0.5. Now if we know the effectiveness, if we know the NTU, we can calculate effectiveness. Now what is the definition of NTU? NTU is given by U0 into A0 divided by C minimum. U0 is equals to 320 is 377 and C minimum is equals to 20. So NTU equals to 6.03. Now the effectiveness equation is given to you and we know the value of Cr and we know the value of NTU, so we can calculate effectiveness. So substitute NTU equals to 6.03 and Cr equals to 0.5. Obtain the value of effectiveness. Effectiveness come out to be 0.974. Effectiveness is given by Ch into Thi minus Tho upon C minimum upon maximum difference is Thi minus Tci. Ch is 40,000, Thi is 120, Tho we have to find out. C minimum is 20,000, Thi is 120, Tci is 20, and effectiveness itself equals to what? 0.97. So check your value of Tho equals to 71.43. Finally, we will go for second formula of effectiveness. So effectiveness equals to, now this time Cc is same as C minimum, so this is get cancelled and we have effectiveness equals to 0.974. Tco we want to find out. Tci equals to 20, Thi equals to 120 and Tci equals to 20. So Tco should come out to be 116. In this numerical we have given a chemical plant of 1000 kg per minute of the product at 700 and Cp is 3.6. Now 700 is a more temperature as compared to what? 100. So is this fluid is a hot fluid? So what is the mass flow rate of hot fluid? Is 1000 divided by is intersat. So what is the value of Thi? is 700. pH is 3600 are used to heat 1200 kg per minute of incoming fluid. So that is m dot c. 1200 divided by 60. Incoming fluid at 100. Incoming fluid at 100 is TCI is equals to 100. Corresponding value of CP, that is CPC, is 4200. If the installed heat transfer area is A0 equals to 42 and overall heat transfer coefficient U0 is 1 kilowatt. You have to compare the fluid outlet temperature for counter and parallel. You have to find out TCO for both cases for parallel counter. So what is CH? CH is given by m dot h multiplied by CPH divided by 60 multiplied by 3600. 0 divided by 60 is 60 into 1000 is 60,000. Only we can find out CC, which is m dot c into CPC. M dot c is 20 and this value is 4200 watt per Kelvin. 60,000 is minimum, 1 is maximum. So what is the value of CR? CR is always C minimum by C max. 0.714 by A0 U0 by C minimum. A0 is 42. This one is 1,000 is 60,000. What is the value of NTU? So in case of parallel flow, effectiveness is given by NTU equals to 0.7 and CR equals to 0.714 and obtain the value of effectiveness. Effectiveness is defined as CH, so that is cancelled. Now THI equals to what? 700 and TCI equals to 100 and this value is same as 0.4077. So from this we can calculate THO. So THO equals to 455.4. We have second formula for effectiveness. CC is 84,000. TCO equals to, we don't know, 200. The minimum is equals to 60,000 equals to 700 is 100. From this we can find out value of TCO. All of you are getting 274. Okay, now for counter flow. For counter flow, effectiveness is given by same as 0.714 and N2 is 0.7. What is the effectiveness for counter flow? So effectiveness is 0.4392. Again we use the same equation of effectiveness that was given here. So same as C minimum, so it is cancelled. THI is 700. We don't know THO. And TCI is 100. Effectiveness is 0.4392. So we obtain THO equals to 436.480. So we have another formula for effectiveness is CC is equals to 84,000. We want to find out. TCI is 100. C minimum is 60,000 minus 100. Is 288 is 0.4392 effectiveness. So mercury with Cp equals to what? 1370 from 150 to 60. 150 to 60 is more temperature of the water. So what we do is that this is what? Hot fluid. So mercury is a hot fluid. Is 1370 is 150. THO equals to 60.25 is m dot h. Naturally the water is what? Cold fluid. So cold fluid enters at 25 degree Celsius and at a rate of 1 kg per second. Cp specific heat of water is 4200. Heat transfer coefficient is U0. is 250. Find out surface area A0, temperature of water, that is TCO. In this case, let's first find out what is CH. So CH equals to m dot H into CPH, and CPH is 1370 3082. CC is m dot C into CPC. M dot C is 1, CPC is 4200 00. So out of these two, CH and CC, this one is what? Minimum. So what is CR? CR is C minimum by C max divided by 4200. 0.73. We have an equation of effectiveness. Now this time we know the temperature of hot and cold. So first of all, we'll use the definition of CH. THI minus THO divided by C minimum upon maximum difference, THI minus TCI. CH is 3082 and is same as C minimum, so this term will be cancelled. THI equals to 150 and TCI equals to 25. So we can find out effectiveness and effective. So is it 0.72? So we'll use the same definition to find out effectiveness, TCO. So effectiveness equals to TC is 4200 3082. TCO we have to find out. THI is 150 25. S is 0.72. So what is the value of TCO? TCO is 91.05. To find out effectiveness, we'll use NTU equation. That is, effectiveness for counter flow is equals to what? 0.72. CR equals to 0.734, and let's solve for NTU. But effectiveness is also given by A0, U0 by C minimum. A0 we want to find out. U0 he has provided equals to 250. C minimum we have already got 3082. So we obtained area A0 equals to. So area is 24 meter square. In this question we have given at industry 0.6 kg per second of oil. Cp equals to 2.5 is to be cooled in a counter flow from 110 to 35, whereas water is entering at 20. It means that the oil is what? Hot fluid. So oil is hot fluid. Of hot fluid is 0.6. Of hot fluid is 2500. It enters at 110, so THI equal to 110 35 degrees Celsius. Whereas we have another fluid is water. So water is our cold fluid. So TCI 20. Overall heat transfer is 1500. But it is also mentioned that the exit temperature of water should not more than what? 80. So indirectly he has given us the value of TCO equals to 80. Heat transfer coefficient is 1500. Water flow rate, that equals to m dot C, and effectiveness. Oil side is known, so can we calculate Q? So Q equals to m dot H into CPH into THI minus THO. Dot H is 0.6 500, THI is 110, and THO is 35. M dot C into CPC into TCO minus TCI 12500. Find out CP of water, is it 4200? Of water is 4200 and TCI is 20. We can find out M dot C 0.44 and value of CC. So we are able to calculate value of CH. Value of CH is m dot H multiplied by CPH multiplied by 2500 Now similarly we can also calculate the value of C is m dot C into CPC is 0.446, for water 4200. So Cc is 1873.2 watts per Kelvin. Out of these two, this is equals to minimum max by C max. That is 1500 by 1873.2 equals to. Now we'll find out effectiveness. Effectiveness is given by Cc. C is 18. TCO is 80. C minimum is 15 minus 20. Effectiveness come out to be 0.833. Our counterflow effectiveness is given by 1 minus equals to 0.833. So we can obtain NTU. Effectiveness is 3.45. 45. But NTU equals to what? A0, U0 by C minimum. We have A0. U0 is provided is 1500. Value of is, and this is 3.45. So area of heat exchanger equals to, into two parts. One part is from parallel flow to this part, and another part is this. The mean temperature difference is LMTD and NTU. You have to solve this problem both by NTU and LMTD. What type of heat exchanger is parallel? And heat transfer uses 1500 kg per hour of cold water entering at 20. So is it m dot C? And to cool 600 kg per hour of hot water. So both fluid are water. 600 kg per second is what? M dot H. And at 70 degrees Celsius. TCI is 25, THI is 70. Exit temperature on hot side is required to be what? 50. So THO equals to what? 50. Is it correct? So let's collect this data. So this one is parallel flow. Is 1500 divided by 3600 kg per second. Enters at 25. It is also water. M dot H is 600 by 3600, 70 degrees Celsius. Exit temperature on hot side, we wish 50 degrees Celsius. CPH is same as CPC. On both sides, that is HI is same as HO, equal to 1600. Find out area by both methods, that is area A0 by NTU procedure as well as by LMTD procedure. That is required for LMTD. So first of all we'll calculate Q. Is the data for hot is given? Data for hot is known. So Q equals to m dot H into CPH into THI minus THO is 600 by 3600 is 1 by 6. CPH is 4200. THI is 70. So this answer come out. Similarly, we can use the same equation for cold fluid. M dot C, CPC, TCO minus TCI. M dot C is 1500 by 3600. We don't know. TCI is 25. Out to be 3. Arrangement is there. We can calculate theta I equals to THI minus TCI is 70 and TCI is 25. Similarly, we can calculate theta O is THO minus TCO. THO is 50 minus 33 is 17. And now we can calculate LMTD. So LMTD is theta I minus theta O upon natural log of theta I by theta O. LMTD come out to be 28.76. Next job is to calculate overall heat transfer coefficient, which is given by 1 by U0 equals to DO divided by di hi plus 1 upon ho. Temporarily we assume the do equals to di, that is the assumption is that it's a thin tube. In that case we can get u0, d0 and di cancel is 1 upon 1600. So u0 come out to be 800. Q equals to a0 u0 into LMTD. A0 we want to calculate. U0 is 800 and LMTD is 28.76. We got area by LMTD approach. Now we have to repeat this procedure by NTU approach. Now we will go for NTU approach. Dot H into CPH. M dot H is 1 by 6 and 4200. 1 by 6 is 600 by 3600 and 4200. Is it 700? M dot C is 1500 by 3600. CPC is same as 4200. This one is 1750. Out of this, 700 is minimum and 1750 is maximum. CR. CR equals to 0.4. We have a parallel flow heat exchanger. So we have effectiveness required first. So effectiveness is defined as C minimum. So this one is cancel out. THI is 70, 50. TCI, THI is 70 and TCI is 25 by 45. Effectiveness is 0.44. For parallel flow, effectiveness is given by 1 minus 0.4 from this obtained value of NTU. Right. NTU is A0 U0 by C minimum. A0 we don't know. U0 is 800. So A0 will be the almost same answer as the previous one, is 0.608. Second part, also calculate the exit temperature of hot and cold if the flow of hot water is doubled, that is 1200 kg per hour. So there is no change of what? Cold fluid. Only the change of what? Hot water. It is doubled. It has been stated that the individual heat transfer coefficient are proportional to point power of flow rate. In second part, we have given that there is no change of cold fluid. So what is M dot C in the previous part? M dot C in the previous part is 600. Now it is what? 1200. Is proposed M dot to the power 0.8. Agree? Now since there is no change in the mass weight of fluid, the heat transfer coefficient also remains constant. Let's call it HI equal to 1600. Hot fluid. So HO, I will say dash, is proportional to the new value of M dot H. That equals to what? 1200 divided by 3600. Is it 1 by 3? To the power 0.8. Whereas the original value of HO, is it proportional to M dot H? Is it 1 by 6 to the power 0.8? And is the original value previously equals to what? 1600. Is this part is clear first? If you take a ratio of this, so this one is 1600 divided by new value of HO is 1 by 6 to the power 0.8 divided by to the power 0.8. So can we calculate the new value of modified value of HO? So if you get 1600 by HO dash, this one is 3 by 6 to the power 0.8. 3 by 6 is 1 by 2. From this you can get the value of H. CC equals to m dot c into CPC. M dot c is 1500 by 600, 1500. CH is m dot h into CPH 1400, and maxim is 750 C by C max. So we want to calculate the overall heat transfer for this modified value is 1 upon HI plus 1 upon HO is plus 1 upon 2785. So we have U0 equals to. Next is, can we calculate NTU? Are you using the same heat exchanger? So area will remain same. A0 into U0 divided by C minimum. Area was previously we have calculated is something 6.608. So this one is 0.608 multiplied by U0 is this value, that is 1016. C minimum is 1400 NTU. So from NTU you can calculate effectiveness. So for parallel flow, effectiveness equals to CR is 0.8. Recalculate the modified value of effectiveness. We have the value of THI equals to what? THI 70 and TCI equal to what? 25. Effectiveness is given by CH multiplied by, we have to use modified value of CH, that is 1400, is same as C minimum also. So this is cancel out. 20. THO we want to calculate for modified data, and TCI is 25. So modified temperature THO equals to, so modified temperature is 56.3. We have second formula for effectiveness is CC is 1750, C minimum is 1400. We can calculate value of TCO 35.94.